Okay. Good morning, students, and welcome to Maths Chef YouTube channel. And this is Suraj Patel. Okay. So in previous classes, we have discussed about the relations and equivalence relations and equivalence class. So today is the wonderful concept functions. Functions is the most potential chapter. Okay. This is the part of the pure mathematics. This pure mathematics is like a root in the tree. Okay. The towards tree system, like leaves and stems, different forms now. Like that, the pure mathematics, but the whole science, not only mathematics, the whole science. Pure mathematics is the root of the science system. If you consider science as a system, it becomes a strong fundamental roots because from here all our system originates. Okay, your stems and leaves like applied mathematics, physics and chemistry, and in medicines, in all fields, in business field, in commerce field, everything else. Okay, this is the pure mathematics. This is the called discrete means I have to study is independent. Okay, and discrete means it is completely different from the others. Independent. Have to study individually. So why it is, how it is, when it is, where it is, like that individually. Discrete studies. Okay. Functions is the subset, a special relation. Okay, where the domain, the input has at least one output. Where all input has at least one in output. Right. Let's take I'm taking the one example. Integer values. This is the z, and this is the z, and the function relation I'm taking here as root x, right? Root x. Again I'm taking the another function, another relation. This is also z, and this is also z, and here r I'm taking r as x square relation, right? Here r is a root x, and here is a x square. So in integer value, this is a 1, 0, minus 1, minus 2, minus 3, minus 4, minus 5, plus 1, plus 2, 3, 4, 5, 6. Right? Is infinite. Continuation. Okay. So this is the input. Okay. This is the input. You can call domain also. This is the input. Right? And this is the output. Okay, this is the minus 1, minus 2, minus 3, minus 4, minus 5, 1, 2, 3, 4, 5. Okay, here is the C. These both are Z cross Z system, right? Integer cross integer, the Cartesian system of the Z cross, both are combined. Okay, just apply these rules. Okay, see for all any square root value only positive. Okay, take the any square roots. Okay, square root of 1 is 1, right? And square root of 2, no, not belongs to. And square root of 4 is 2, and square root of 9 is 3, right? So we have only 1. Okay, sir. Z cross Z is, I am writing 1, 1, and 2, 1 or 2. This is 4, 2, and 9, 2, etc. Right? For Z plus C. Here negative elements are not considered because negative of x is not belongs to Z. Right? Negative elements are not considered. Only positive element. I have taken again either the gap 2 and 3, 5, 6, 7, 8. So there is a gap between the numbers. So this is a relation. So relation, it does not matter whether the input means domain have the at least one output, at least exact one output. So it does not matter. A relation is any relation. Right, sir? Any corresponding. This was the 1, 1, 1, 2, 3, 1, 2, something. We can write the C. Minus 5, actually we can here. Minus 5, minus 1 you can write. So minus 5, minus 4 means you can add a minus 4 for a. This is the relation. Because here minus 4 is adding here. Again minus 4, minus, okay, again minus 6, minus 10, minus 14. Okay. Randomly, we can create infinite relations. Right? But it comes to the, okay, this one. Right? This one, I am taking 1, minus 1, minus 2, minus 3, minus 4, minus 5, plus 1, 2, 3, 4, 5. Okay. That is the integer input also, but I am taking here also a. Right? Here also a. Can take a or something else. You can take also y or b. Right? So here a is subset of z and b is subset of z. Right? Consider for 0 square we have 0, for 1 square we have 1, for 2 square we have 2, for 0 square we have 1, and 1 square we have 1, minus 1 square we have 1, and 2 square we have 4. Right? I am writing this one as right. Very important. And minus 2 square have 4, and 3 square have 9. Right? And minus 3 square have 9. Right? Here we have 2, 3, 4 also, 5, 6, 7 you can write, minus 1, minus 2, minus 3, minus 4, minus 5. Right? Similarly, I am marking here 4 to 16, 4 to 16, 5 to 25, 5 to 25. Okay. All elements. Right, sir? This is infinite. See, I have taken the all elements. Very important here. The relation is a is a function from f r is. So here I am writing f. Okay. F is a function from a to b. A and b belongs to z. Right? Subset of z r belongs to b also. Is I'm filling this one as I am writing subset of z. And a and b are subset of z. So f is a function from a to b. Right? One thing I have made the infinite here. Dot 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 dot. Because to show function has one output of at least one output for the one image, one input. Okay. In function we should exhaust all inputs, and every input at least have one output. Okay. Confusion. 2 also 4 and 2 also 4. That is okay. But that is not possible, right? One number should not give, okay? One number should not give minus 3 and minus 1. That means minus 1 and 1 and minus 1 and 3 is not a function, right? Not a function. Means one input should not have more than one output. Very important. One input, one element of the domain should not have the more than one element of the element in the image codomain. Right, sir? I am telling, see here relation have the many inputs, but you have taken the only single some special relations to something else. But here you are exhausting the every element of the domain. Input, output, domain, codomain, image, pre-image, okay, function, range, right, sir? Domain, codomain, image, pre-image, and range also comes here, right? F is a function from A to B. Okay, sir. See here we can have more any element which is not related to X, right? A. In B, in the codomain, we may have more elements which are not related to domain, but domain should at least have one image in the codomain, right? Every element of a domain must and should have at least one image in the codomain. That's the function, right, sir? Understand? So one thing is completely every element of the domain should have at least one image in the codomain. This is the main definition of the function. So this is the relation, that is the function. Relation, domain, randomly we can take. They may be related or not related, but have many uses. Every element is related to other element with some different rules, different relations. Okay, sir. 1 and 2, see 1 and minus 2 have adding 0. 1 and minus 2 have, see one element can have many elements here. Right, sir? One element can, from one we can make a millions of billions of relations from only one. Just add the C. Take one as, right, sir? So B is A plus 1. See, 1, see here, A is belongs to R, right? A belongs to, which one? A belongs to Z, right? Okay, if you taken the one, okay sir, taken the random, see one here, na? Here, the only one, creating all elements. Yes, one element, because we are adding this one to all elements. It gives another relation. That is the fundamental difference. Okay sir, in relation you can make any type of relations. But in function, when you define the function, we should consider the all elements of the domain. Okay. Let's define the function technically in definition as it is in the book, right? The function is, right? Definition, right? Definition, if, okay sir, if x and y are non-empty sets, right? Non-empty sets, right? Non-empty sets, then a subset of x, then a subsets, right? Subset, not subsets. Subset F, where is very important, F of x and y, of x class y. This is capital X and small cross and capital Y. X and Y is called function, is called a function or mapping, right? MPPAING, mapping or map from x to y, if, for this again, if means if and only if, right? If for each x belongs to A, okay sir, for each, very important, for each, I told you na, domain, you should consider the domain elements. For each x belongs to x, there exist, this is the symbol of there exist, I can write the there exist also, there exist a unique y, a unique y belongs to y such that xy belongs to, okay sir, this is the order pair, xy belongs to f. It is written as f is a function from x to y. Written as f is a function from x to y. Right sir. This is the definition as it is in the book. As exactly it in the book. Right? If x and y, okay sir, again I will show you the diagrammatically. Let's see. Right, is the function. This is the function. This is the x, and this is the another column y, and this is the symbol of function. This is done by f. Right. Yes. Now here we have x1, x2, x3, x4 up to infinite. Here we have y1, y2, y3, y4, y3 infinite, and this is the canary. Function is, okay sir, it is also y is equal to f of x. You can write here also. Let's write the function as it is. Right? For the definition, if x and y are non-empty sets, then a subset f. Yes, then subset f. Okay, subset f means this is the subset f. This is the f. The whole is y. Subset f of x cross y. Right? X cross y. Okay, here you can write also. Okay, x1, y1. F is like that. You can write x2, y2. Okay, you can write also infinite. F is called function or mapping or map from x to y if for each elements of x. Okay, sir. For each elements of x, there exists a unique y belongs to y. Right, sir. Okay, this is the symbol. Right? There exists a unique y belongs to y such that xy belongs to f. Okay, sir. This combination, right? x1, y1, x1, y2, x2, y2, x3, y3, and unlimited, infinite. This is denoted by, this is denoted by capital X from the capital Y. Okay, and here simple. This is called domain. Input domain denoted by domain of f. Right, sir. And this is called whole y is called codomain. Codomain. Right? And this is called, this small subset is called, means f. Listen, y is equal to f of x. Very important. Okay, means these are the only values by getting the inputs. Okay, values of x, values of domain is called range of f. Right, range of f denoted by r of f. Very important. Values of x are values of x or domain, right? Domain x belongs to D, right sir? This is the domain, input is called domain and this is called codomain, and the values of the functions are called range. So obviously range is a subset of codomain. Range of f is subset of codomain. Okay, subset of codomain cancel, and this the set is called also images. Yes, sir. This is also called images. Okay, this is called pre-images. Pre-images. This helps in the inverse functions, right? Image and pre-image helps us in the inverse, defining the inverse of the function. Okay, this is the image and this is the pre-image. Domain, codomain, range, codomain. Okay, and values. These values, see, almost images, values, domain, range, codomain, all belongs to the this right part only, result part only, right? Yes, sir. This is the subset, okay? Writing, but in function we are not defining, but order pair, okay? Any functions in algebra, right, sir? In algebraic, okay? This is the upright part of the algebra, the pure mathematics. This consider the function underlying f of x is equal to x square plus x plus 1 is the function, right? Any polynomial or something else here. For all, this is called y, okay? For every, this is our right. You can take x as random numbers, random integers, sets, real numbers, whole numbers, natural numbers, okay sir? Means here for every x you will get a y. For every x you will get a y. 1, 2. For every x you will get a y. Means corresponding value of x you will get the corresponding value of y. This is the order pair. Okay, so but it is usually not defined in the, not noted in the algebraic expressions, but okay, by definition, by mathematically, by conventionally, we should know this is x is our side. We have to take the random values. We will give the conditions. Okay, for every condition, they will get a one value corresponding to one or two values. Okay, this is the basics, right? This means it has a completely ordered pair, two ordered pair, x, y, x, y, x, y, x, y, x, y. That relation is a function, right? Let's define the domain and codomain and the technically how it in the books, right? Yeah. Next, see, I read the book. Reading the book means only to define the technical terms, right, sir? So, in the spelling is different and technical knowledge is different because you have to understand what is in the book, right? The domain is domain. Okay, sir. First one is domain. Domain is right. Let f be a function from x to y. Let f be a function from x to y, right? Capital X to capital Y, right? Then the set x is called, okay sir? Then set x is called right, domain of the function f, okay sir, domain of the function f. Very sir, this is the not only what is the domain is with respect to function, domain of the function, not domain of the set, domain of the function. and y is called codomain, and y is called codomain. Codomain, right? So for the range is, that is the range is, okay, the set consisting of all the images of the elements of X. Together, the set consisting of all the images of the elements right, of X under the function f, under the function f is called right, is called range of f, range of f. Alright, so I read the books, so I think this is almost far more better than the PPT. If I have PPT now, so I could have explained it in clearly easiest way with written words, but because now these definitions are very important, okay. Exampling is simplest for, but again defining mathematical is also very important to grasp the exact notation, the graduation, post graduation. So that's why writing there. The domain is, let f be the function from x to y, then set x is called domain of the function f. Domain of the function f, right sir? Complete sentence here. And y is called codomain. Range is the set consisting of all the images, right sir? Set consisting of all the images of elements of X under the function f is called range of f, right? And denoted by f of X. Yes, sir. This is denoted by f of X. F of X is range. Okay, sir. And this is denoted by d of f, domain of f. This is okay, sir. And also we have the range of f, right? Can also range of f, can write also range of f is equal to, right sir, f of x, okay sir, such that x belongs to capital X. Can I write this one as yes? Is it right now? F of x, right? R of f is equal to set of f of x is equal to this one, x belongs to x, and obviously you know Rf is subset of codomain. Subset of codomain means codomains you have the more elements which are not related to domain X. Codomains you have the more elements which are necessarily not related to X. So range is all elements are related to X. Range is compulsion. But codomains have the liberty. They can do any elements, they take any elements. Domain, range, and okay, sir. Then domain, main feature of the function. Okay, sir. I will again at the time, the cost of your time, again I am writing the every points, every elements, every concept in the on the board, only for sake of you only, right? Main features of the function. I will write and explain the things properly, right? main features of the function, and again I will tell you, right, main features of the function. Yes, sir. Main features. Main features of the function, of a function, of a function. Okay, sir. Because why we do study this in deep means, this is the fundamental. Okay, sir. See, if you are sitting somewhere else, you can collect the random numbers, random type of numbers. Okay, this is the origin of almost all that, the integer numbers, irrational numbers, real numbers, complex numbers. Okay, sir. This is the base for the all mathematical inventions. Okay, first one is, right, let f be a function from x to y. Consider, okay, sir, before this one is, let f be function from, right, x to y, then, right, first one is, to every x belongs to, right, x belongs to capital X, there exists a unique element. Right, sir, I am writing this symbol. There exists symbol. This is, there is a unique element. There exists a unique element. Unique element. Unique element y belongs to capital Y, such that capital Y, such that y is equal to f of x. Right, sir. For every x, there will be unique element of y. Okay, in x square, now if I take an x squaring is the square of the number is the function. Right, sir. Here, if I take the x square, f is here, square of the number. Okay, sir. Square of the number of the input. Function name is, if I take y is equal to x square, or f of x is equal to f x, or y is equal to f of x is equal to x square. Here na, f is square of the number. Definition: the cube of the number, minus of the number, plus of the number, power of anything else, sir. F is defined infinitely, different values. So it is like that, such that for every element there will be a, see, for 1 you have 2, for 3 you have 9, for 4 you have 9, 16, for 5 you have 25, like that. This is the, okay, sir, this is the f of x, means only value obtained from the x. Okay, right. Second one is very important here, very important. I am going to star function here. No element of, okay, sir, no element of x can have more than one image in y, can have more than one images in y, one images in y. This is very important. See, according to this function, right, I'll explain here. See, 2 and 4, right, and minus 2 and 4 are functions, right? This is the function. But, okay, sir, 2, right, 2 and 4, right, sir, and 2, not minus 2, 2 and minus 4 is not a function. Here, very important. You can have 2 input to get this 1 output, but you cannot get the 2 output with 1 input. That is never possible. because we have to take in algebra, I have to take one value. If x square is equal to algebra equation, x is in our hand, we have to take only one value at a single time. See, in mathematics or in science, we do not have the number, okay, so it plays a dual role. So 1 is 1, minus 1 is minus 1. So it not results 2 values, 3 values. Itself, the fundamental, you do not have two numbers, two duality. So quantum mechanics, that is the complex, right? Unlike in quantum mechanics, right? So in 2, if you add, see, if we for one value 2, we never, okay sir, we never ever get the minus 4. Take any function, any value, any type of the function, we never ever get this one. If it's getting 1, that becomes relation. If you are getting, this become different relation and this become different relation. Add plus 4, take in negative 4 here. Subtract minus 4. This one relation, this one relation. But this never becomes function. Right? This is the thing. No elements of x can have more than one images in y. Right? No, okay sir. But the no elements of x can have more than one elements in y. So this is the one. 2, 2, 4, minus 2, 2, 4, 2, 4, this is defined, that is x square. 2, 2 square 4 and minus 2 square 4 defined, but this is reverse is not defined. Very important, right? Next one is okay, this example is very important for NDA also. NDA series, they often see the NDA, they occasionally, often they use this question tricks. Okay, third one is, next one is, there may be elements of y, there may be elements of y, capital Y, not small y, capital Y, which are not associated with any element of x, which are not associated with any element of x, any element of x. That's called codomain. Means codomain, we have more elements of x. This is the x. See, this may be a 1, 2, 3, 4, but domain may be a bigger one. X and y. X and y. Right? Right? Yes. Domain may be bigger, and codomain may be bigger, but x is smaller. Codomain you can have more value. There may be elements of y which are not associated with the any elements of x. So okay, can have, but here also can have the. This is called range, right? Let me next define the question, right? Next one is fourth property is distinct elements of, okay sir, distinct elements of x, may have same image in y, may have same image in y. Distinct element of x, plus 2 can become 4 and minus 2 also become 4, but never, okay sir, 2 becomes 4, right? And 2 gives minus 4. distinct element of x may have same image in y. Same image, this is so minus 2 and 2 gives rise to 4. This is right. But 2 should not give minus 4 and plus 4. This is wrong. One element. Yes, sir. Means in mathematics and physics we do not have the element which plays a dual role. But two elements can play a single role. Similarity. Two elements can play a single role to become a single common element, common result. But single element we do not have the dual role. Okay, sir. Unlike position and velocity of the Heisenberg uncertainty principle, right? There we cannot possible to find the position and velocity at the same time. At same time, it's completely uncertainty, impossible. Either we find the velocity or either we could find out the position, because moving body either has velocity almost. If you want to find the position, it has to stop. It becomes rest. The velocity is 0. If it is moving, position it becomes random. We cannot find. That's all. See, mathematics we do not have a single element which plays a different roles. Right? Fourth one. Fifth one is function f is determined by the when fx is okay. Function f is determined when f of x is known for all x equal to x. Next one is, fifth one is function f, right? Function f is determined, right? Determined when f of x is known for all, x belongs to x. Means if all values of x have some images in y, then we define the function. Function f is determined when f of x is known for all x. Only all values of x. If you consider the all values of x, then you can define the function. Otherwise, it not become a function, right? That's all. Okay. Another concept is real valued function and a real function. Again, next concept is, okay, these are the very important. Once I already revise the concepts. Let us be a function from x to y, then to every x belongs to x, there exists a unique element y belongs to y such that y equal to f of x. Okay, sir. Means every element in y, in f of x, we have the one unique element for x, right? No element of x can have more than one element in images in y. So, right? Single one element, one domain, one image. One pre-image, one image, one input, one output, right? There may be element of y which are not associated with any element of x. Codomain. Property of the codomain means we can have it. Distinct elements of x may have same images in y, right? Minus 2, 4 and 2, 4, right? Functions f is determined when f of x is known for all x belongs to x. That's the range of x. Define the range of x. Want to define the function, you should exhaust the all domain values. Next is the difference between the real function and real valued function. Okay. Real function and real valued function. Okay. Real function and real valued function. Real valued function. Okay, sir. This is the term here. Real function is, okay, sir, domain of f is belongs to R, or domain of f is belongs to subset of R, right? Domain of f is belongs to R, domain of f belongs to subset of R, right sir? Simple only. A real function is, if the domain of the f belongs to R, domain of the f belongs to subset of R, that is called a real function. Real function is range of f. Where is sir? Range of f belongs to real value, real number, right? Or range of f is subset of real number, right? The real function is concerned to domain, and the real world function concerned to which one? Real world function concerned to range, or real function concerned to domain, right sir? Domain of x can write domain of f is equal to x such that x belongs to R and f of x also belongs to R, and the range of f is equal to, right sir, range of f is equal to set of f of x, right sir, such that f of x belongs to R and x belongs to R. Power. This is the difference between the real function and the real valued function. Okay, this is the okay. Here if writing as this one can also write d of f, right? Because we're taking this one. Yes, this is the call. Yes, this is the, I think so. Next, okay, remarks are there. I will read it. So remarks: a function does not exist if it is domain is empty set. Means empty set does not have any function relation, right? If the domain of a real valued function is given, then we are not to find the admissible subset of R. If the domain of the real valued function, the range is there given, then it's not possible, it's not necessary to find the domain, okay, subset of R. If the domain of the real valued function is given, then we are not to find, right? Then distinctive property of the function is that for given element x of the domain f of x, domain f of x uniquely determined element of codomain. Means every x you have the any one f of x. This is the problem. For every x, you have the unique f of x. And some notes are there, formulas. We will define this one. Yes, sir. Some important formula there. Okay, sir. Notes you can tell also. I am explaining how it is also. Notes. If A and B, okay, sir. If A and B are real numbers, right? Such that A is less than B, then okay, sir, one very important one, x minus A into x minus B is less than 0 if and only if x A is less than equal to x less than equal to B, only if, okay sir, again if and only if x belongs to open interval, right? Open interval, right? Let's take the, okay, sir. I will simplify take one example. Let's take 2 and 6. I will take this one as, and x belongs to this one, and x becomes I value 3, right? After this condition, okay, 3 minus 2 into 3 minus 6 becomes 3 minus into 1 into minus 3 becomes minus 3 is less than 0. Okay. This is the condition. Here now, when you got some functions in this form, you can write, okay, x minus a, x minus b is the function, okay, the value of x is in between the a and b, then immediately by applying this theorem, by knowing this theorem, this result, you can tell this is less than 0. Okay, you can check also. Similarly, you have the 4 system, okay, 4 numbers, 4 theorems, 4 not theorems, identities, you can tell also. Second one is, right, x minus a into x minus b greater than or equal to 0 if and if a is less than or equal to x less than or equal to b, if and if, okay, x belongs to closed bracket of closed interval of a and b, closed interval including the values given values. And the next one is x minus a and x minus b is greater than 0, okay, if either x is greater than 0 or x is less than y, right, x is less than y and x is greater than b. Again, if x belongs to minus infinity to a union b to close to infinity. Okay, sir. I'll explain again here. Again, after taken x belongs to 2 and 6. Okay, sir. If the value is outside the, okay, sir. Yeah, if x equal to, I taken x equal to 1, condition becomes, right, sir, 1 minus, okay, 1 minus is the a and b, right, 1 minus 2 into 1 minus 6 becomes, okay, sir, minus 2 into minus 6 becomes minus 5, minus 5 becomes plus 10, which is greater than 0, right, 1 minus 2, 1 minus 6, minus 2, minus 5 into becomes 10 greater than 0. Similarly, if I x taken as 7, right, 7 minus 2 and 7 minus 6, both are positive now. 5 into 1 becomes 5 greater than 0. Okay, that is the condition. You can prove it by taking also. Okay, if x minus a, x minus b greater than 0, if either a is less than, beyond the bracket, close bracket, a is less than 0 and x is greater than, a is less than a, or this is the r symbol, OR, and x is greater than b. Okay, sir. This is the symbol. And next one is, fourth one is similarly same, x minus a and x minus b are equal to 0 again, right? Okay, if x is less than or equal to a or x is greater than or equal to b, that is x belongs to, okay, sir, minus infinity to a, half close, okay, union, not b, union half bracket close b to infinity, right? These are the 4 symbols. Again, a fifth one, they are not mentioned in the books. Okay, sir. Then, okay, sir, if f of x is equal to root of x, okay, sir, root of x, and f of x is greater than or equal to 0 for all x belongs to R. Can I write R? Okay, sir. R plus you can write for R plus. Only positive numbers of the real numbers. Positive part of the real numbers. And sixth one is if f of x is equal to x square or any two even numbers. Okay, sir. 2n and n belongs to n. Right? Right? And then f of x is again greater than or equal to 0 for x belongs to R. Any value. Here there. 2 to the power n. Even number. N belongs to n, f of x becomes 0 and for x belongs to R. For any values of R, we will get positive number. Again, seventh term I am telling f of x is equal to 1 by x, right? Then again also, right? As f of x is greater than or equal to 0 for all x belongs to R plus. Okay? 1 by x also. These are some identities. Okay, sir. Here we don't need the things, the part of problems also. So root of x also positive, x to the power n also positive, and 1 to the power x also positive for corresponding R plus and R for the 2 years. I think sir, okay sir. This is the greater than 0 for x going to R. X square, not only x to the power n, right? And I have to define 1 onto 1 many 1 onto into onto, but I think so time is not allowing us to continue. I think so. Yes sir, it's already near to 1 hour. So next class we will define the different type of the functions and we solve the question based on the these definitions. I think so. This is a functions relation. So I explained it wonderfully. Okay, I even used the book to give the exact definition. That's a technical definition of the functions. Okay, these are very important. Okay, by solving came to know how it is. Okay, and please comment on the comment box for any feedback, positive, negative, neutral, right? And thanks for watching the video. Thank you.